Hello, this is Lisa. We're going to talk about linear inequalities in this video. Inequalities compare two quantities. First thing we're going to do is talk about what the symbols mean. When you see the symbol pointing towards the 7 or pointing towards the left, it means 7 is less than 8. When the symbol has a little bar under it, it means it can be less than or equal to. So or equal to has the bar. 25 is greater than 5. 25 is greater than or equal to. The equal to, again, has the little bar underneath. In the next two examples, we're going to talk about changing the direction of the inequality sign without changing the meaning of the statement. We're going to flip everything around. 42 is greater than or equal to 7 is the same as saying 7 is less than or equal to 42. Now notice in this example, when you look at the inequality sign, if you were to do an arrow, your arrow would look like that. It points towards the 7. So does the inequality sign. When we flip it around, it still points towards the 7. X is less than 3 can be written as 3 is greater than X. Again, you want to make sure that the inequality symbol is still pointing towards the same quantity. When we write solution sets for inequalities, we're going to do them as graphing an inequality on a number line and using interval notation. So when we graph an inequality on a number line, we draw a real number line. The real number line is a horizontal line. A lot of people put 0 in the middle, but it could start anywhere you want to. And you count positive numbers going out to the right, and they go out towards infinity. In other words, it continues on forever. And you mark units to the left if they're negative. And negative infinity is where we're headed to when we go all the way out to the left-hand side. You're going to shade to the right or left of the number, and you're going to use a parenthesis or a bracket at the number in your inequality. And we'll do some examples in a minute where you'll see what that looks like. When we use interval notation, we use either parentheses when the endpoint is not included in the solution set. For example, when we have less than or greater than inequalities. And we use a square bracket when the endpoint is included in the solution set. In other words, when we're using less than or equal to or greater than or equal to. And we use a parenthesis every time we have infinity or negative infinity. And the interval from negative infinity to infinity represents the set of all real numbers. So let's do some examples here. Graph the following inequalities and write the solution in interval notation. So I'm going to draw my number line. Negative infinity to the left, positive infinity to the right. And here it says x is greater than 5. So I like to identify where 5 is on my number line. And to determine which way I'm going to shade, I'm going to pick two test numbers, one on either side of 5. And I'm going to replace x with that number. Is 4 greater than 5? No, it is not. Is 6 greater than 5? Yes. Then we're going to shade from 5 in the direction of 6, so off to the left. My inequality sign does not have the equal to part. It is strictly greater than, so I'm going to use a parenthesis. So this is what my graph looks like. And when I write the interval, I look at where my shaded region is on my graph. I look at where the left edge is and where the right edge is on my graph. And the left edge is going to be the left edge of my interval, parenthesis 5, comma, and then I go out to the right-hand edge, it's infinity, and infinity always gets a parenthesis. So there's my interval for that inequality. We're going to do the same thing now for x less than or equal to 2. I'm going to start by drawing my number line. And I'm going to pick up, there's my 2, so my test numbers, I'm going to pick one to the left and one to the right. Is 1 less than or equal to 2? Yes. So that indicates that my shading should go in that direction. You can double check though, is 3 less than or equal to 2? No, it's not. So we know we're going in the right direction. My inequality sign this time has an equal to part. So when it's equal to, we're going to use a square bracket. And then when we write our interval, again, we look at what's on the left edge and what's on the right edge of our shading. Negative infinity, always use a parenthesis, comma, we're going out to 2, and this time we said 2 can be equal to, so it has a square bracket. And that's what the interval for that inequality looks like. And next we're going to write an inequality using the variable x that corresponds to the graph of the solutions on the number line. So here's my number line, and I have a graph here. I want to write an inequality with x that corresponds to this graph. So I'm going to have x, and I'm going to have to think, is x greater than, less than, greater than or equal to, less than or equal to? So a couple of things that I'm going to look at. The direction that the shading goes in, it's going out this way. So these numbers are getting bigger and bigger and bigger. It means x is greater than -1. Is it greater than or equal to? Well, now I look at my square bracket, which tells me it should be greater than or equal to 1. So the inequality here, x is greater than or equal to 1. Look at the shading and look at whether it has a bracket or a parenthesis. When we're solving a linear inequality, we're going to use essentially the same steps that we did with equations. Simplify each side of the inequality, use the addition property or principle, use the multiplication principle to get the variable by itself. Now, this is the one step that is different from equations. When you multiply or divide both sides of an inequality by a negative number, you must switch the direction of the inequality sign. Give your solution as a graph and in interval notation and check your answer. So let's do some examples. This time my inequality sign divides my inequality into two sides, the left and the right. In order to get x by itself, I have to subtract 7 from each side of my inequality. I'm not dividing, so I don't have to worry about changing the direction of the inequality sign. I'm going to have x is less than 10 minus 7 or 3. Draw your number line. Find your number. 3. X is less than 3. So now I'm going to pick a number to the left and a number to the right. Is 2 less than 3? Yes. So we're shading to the left. No equal to part on my inequality sign, so I'm going to put a parenthesis at 3. And my interval then becomes parenthesis negative infinity, comma 3 with a parenthesis. Always matching same order as the shaded region on my number line. Negative 3x is less than or equal to 15. Divide both sides by negative 3. Oh, we're dividing by a negative number, so it's going to change the direction of the inequality sign. Less than or equal to becomes greater than or equal to. X and 15 divided by negative 3 is negative 5. I'm going to draw my number line. You do not have to use individual units. When I have a number like negative 5, I oftentimes will put my little tick marks here in units of 5. Remember, positive numbers to the right, negative numbers to the left. I'm going to find negative 5, and I'm going to do my test numbers. 1 to the left, and I can pick a number to the right. I don't like to use 0. I'm going to use 5. And I'm going to say is 5 greater than or equal to negative 5? Or is negative 10 greater than or equal to negative 5? This one happens to be correct. Means I want to shade to the right. I have an equal to part on my inequality, so I'm going to use a square bracket. And my interval then becomes square bracket -5 to infinity, and always a parenthesis at infinity. 3x is less than 2x plus 5. Again, starting with my addition principle, I'm going to subtract 2x from each side of my inequality, leaving me with x is less than 5. Graph it. Identify your endpoint is 5. Is 0 less than 5? Yes. Then we're going to shade to the right. Sorry, shade to the left. No equal to part, we use a parenthesis. So we're going from parenthesis -infinity to 5 with a parenthesis. -2/3 x is greater than or equal to 8. We're going to clear the fraction first. So I'm going to multiply both sides by 3. 3 divided by 3, that cancels, leaving me with -2x is greater than or equal to 24. I multiplied both sides, but I multiplied by a positive number, so it does not change the direction of the inequality sign. Now I need to divide by -2. There's the step that does it, though. I'm dividing by a negative number, so I need to change the direction of my inequality sign. X is less than or equal to -12. On my number line, I'm going to do units of 10 this time. And I'm just going to make a little special mark here. Right about here would be where -12 is on my number line. And then I have to see, is -20 less than or equal to -12? Or is 10 less than or equal to -12? 10 is not less than a negative number. I know it has to go to the left. We have equal to in our inequality, so we're going to use that square bracket. And our interval goes from parentheses -infinity to -12 with a square bracket. One more inequality. This time we need to distribute to get rid of the parentheses first. 2x minus 10 plus 3 is greater than 9 minus 2x. I have some like terms here. I can combine my like terms. 2x minus 10 plus 3 is minus 7 is greater than 9 minus 2x. I need to get my x's together. I'm going to add 2x to both sides of the equation. 4x minus 7 is greater than 9. I need to get all my numbers on the other side. I'm going to add 7 to both sides. 4x is greater than 16. And to get the x by itself, we divide by 4. Dividing by a positive, so the inequality sign stays the same. X is greater than 4. Going to draw my number line. Identify my number. My endpoint is 4. Is 2 greater than 4, or is 6 greater than 4? 2 is less than 4, so 6 is greater than 4. I'm shading to the right. I do not have equality in my inequality, so I'm using a parenthesis. And my interval, parenthesis 4, comma, infinity, with a parenthesis. And that concludes the video on inequalities. Have a great day, everybody.